Hey, all, today we are going to continue talking about proportions. We're going to continue talking about confidence intervals and putting that together. We are going to talk about confidence intervals now for two proportions. So last time we tried to estimate a population proportion, one population proportion, using a confidence interval. And this time we're going to try and see if we have two different groups, if we can find the difference in the proportions from those groups. So we'll have two proportions, and we want to see if we can capture the difference. Um, all your learning targets information about the unit is there on Canvas for you. So I want you to pause and take a minute to read this, and then press play and continue. So we have this study done in Massachusetts. Um, You're looking at seatbelt use. They want to see if there's some sort of difference between when a male driver is driving a car with a female passenger versus when a male driver is driving a car with a male passenger. And in particular, what we're looking at is the proportion of those drivers that are wearing their seatbelt to see if perhaps the men are taking more risks when depending on the gender of their passenger. And so we want to find we can find a sample difference. We have a sample proportion of male drivers who wore their seatbelt when they had a female passenger. That's down here, 66%. We have 49.3% who wore a seatbelt when they had a male passenger. Those are both sample proportions. They're different samples because we are looking at two different things, a female or a male passenger. And we could find a sample difference. We can subtract 66 minus 49.3. In fact, I'll do that. So I'm going to say p hat for a female passenger minus p hat for a male passenger is 66 minus 49.3, and that is 16.7%. So from our samples, there's a 16.7% difference. 16.7% of the drivers with a female passenger wore their seatbelt, 16.7% more than with a male passenger. But we want to try and estimate the true difference. If we were to look at all male drivers who had a passenger, what would the true difference in the proportions between a female passenger and a male passenger be? And so we use a confidence interval. We call it a two proportion Z interval. Uh, last time we were doing a one proportion Z interval. Now we're doing a two proportion Z interval because we have two of them. It's still a Z interval. So we're still going to be using that Z star critical value that you can calculate using the inverse normal function on your calculator. We still have a standard error, which is right here. It looks a little complicated, but it's basically the standard error for um, one proportion, but two times. And that Z star times our standard error is still our margin of error. And we have a point estimate. That's our point estimate that we just calculated. That's 16.7%. It is an estimate that we would get from one sample of each group. It's one possible way that we can find the difference out of the countless number of ways we could sample male drivers with male passengers and male drivers with female passengers. Z-star again, we calculate it in the same way based on the confidence level, 99, 95, 90, 80, so on and so forth. We can use inverse normal. You might get used to those values and just memorize them. Much like in the one proportion, we can find on our calculator if we hit stat tests, it's choice B. It's a two proportion Z interval. And I do have my calculator today. So I can hit stat, go over to tests. I'm going to go down. And it just happens to be right below the one proportion Z interval. It's the two proportion Z interval. It's choice B. And it's going to give us a place now to enter two X's and two N's because we have two samples. We have two groups. And remember, X is the number of successes and N is the sample size. And of course, you put your confidence level in there and it could calculate a confidence interval for you. And that's how we're going to do it. We'll use the calculator. So I want to go back up here and I want to document some things. I want to document my p-hats for a female passenger is 0.66. That makes my q-hat for a female passenger 0.34. My number of successes when I had a female passenger, that is the number of drivers who are wearing their seatbelt, is this 2,777. And then my sample size was 4,208. I'm getting this from the problem up there. I'm gonna pause quick and document that for a male passenger, and then I'll talk. So again, I grabbed all of that from the problem. I'm getting my Q hats by subtracting my P hats from 1. We were given our X's, we were given our sample sizes, N's, and so it's good to document all this stuff so that we can use it in our calculation. So we're going to answer a question using this information, but of course we have to make sure that we meet assumptions and conditions. Our sample needs to be randomly selected. In this problem, and I'm actually going to do it right here on the sheet this time. In this problem, they do say they did random sampling methods. Okay, so we are told that random sampling methods were used. Of course, remember when you're doing a problem like this on a test or the AP exam, you're going to want to use complete sentences. So you could say that the 4,208 male drivers with female passengers and the 2,763 male drivers with male passengers were selected using random sampling methods. It's important that we have independence in both groups. So both groups need to represent less than 10% of the population so that the seatbelt wearing habit of each driver is independent of the other drivers. I would say that 4,000, approximately 3,000, 2,700, that number of passengers is big, but I would say that's less than the number of drivers on Massachusetts highways. Decent sized state, decent sized population, they're going to have a lot of drivers. So in this case, both groups represent less than 10% of the population. The other thing that I put here in red that's really important is we need to make sure that these two groups aren't tied together in some way. We need them to be independent of each other. So my male drivers with female passengers and my male drivers with male passengers need to be independent of each other, meaning one group is not influencing the other group's seatbelt wearing. I see no reason why one group would influence the other. And so we can say that both groups are also independent. So you want to document your independence for both groups individually, as well as saying that they are independent of each other. Because if they're not independent of each other, this is a different type of test that we're not talking about. And then, of course, we need to establish that a normal model is appropriate for both groups. I'm going to change this little N and Q down here. We don't have population proportions or P's and Q's. We have samples, so I'm going to put the little hats on there. And so we can check NP and NQ. I'm going to pause and do that, and we'll chat about it. So we're going to calculate NP and NQ for both groups. What's really nice about this problem is we're told what NP is. Our number of successes for the female passenger was 2,777, and our number of successes for the male passengers was 1,363. That's our X, the X that we're using. And so we can subtract those from the total sampled in each group to find NQ. And these are way bigger than 10. We're totally fine to use normal, the normal model. And so now let's peek at the question and answer it. We want to know how much difference there is in the proportion of male drivers who wear seatbelts when sitting next to a male and the proportion who wear seatbelts when sitting next to a female. So let's recap. We did We did our female group minus our male group, and we got 16.7%. We can do it either way. One way will give us a positive number. One way will give us a negative number. We just need to make sure that we interpret those correctly. I'm going to do it this way, and if you want to do the other way in class, we can totally do that. So I'm going to go to my calculator, and I'm going to do a two proportion, a two prop z interval. And you always want to write down what interval you're using, especially if you're using the calculator. So I'm already there, but I'll quit out and I'll do it again. I'm going to hit stat, tests. I'm going to go down to option B. My X1, N1, I'm going to use from my female group. So my X is 2,777. My N is 4,208. My X2 and N2 are going to come from my male group. That's the one I'm subtracting. So X is 1,363. N is 2,763. We're going to do a 95% confidence interval. Again, I picked a problem where they didn't tell us what to use, so we'll use 95%. That's always a safe bet if you're not told, but typically you will be told. And then we're going to calculate, and we're going to get our interval. So what we need to do is make sure that we interpret this correctly. There's sort of three elements to doing a confidence interval. We need to establish that we're allowed to use the procedures. We need to do the calculations, and then we need to interpret our results. So you're sort of justifying, calculating, interpreting, justifying, calculating, interpreting, and that's sort of going to be our method as we go now for the next several months. So I'm going to write down the interpretation, and then I will explain it. So again, we can sort of use the formula. It's just adjusted a little bit, though, because we have to compare between the two groups. So we need to use a comparing word. So we can be 95% confident, state our confidence level. We're talking about proportion, so we want to say the proportion. And then we want to add in our context. We're talking about male drivers who wear a seatbelt. And then we are comparing the seatbelt wearing when you have a female passenger and a male passenger. And we found that in our sample, we found the female passenger group to wear their seatbelt more frequently. And so this 14% to 19% means that we can be 95% confident that the proportion of male drivers who wear a seatbelt with a female passenger is between 14% and 19% more than those with a male passenger. So somewhere in that area is the percent difference in seatbelt wearing when you have a female versus a male passenger. You want to compare. One group is more than the other. If we had subtracted the other way, if we had switched which group was X1, N1, X2, N2, we would have got some negative numbers, and that wouldn't mean we were wrong. That would mean that the passengers or the drivers with a male passenger wore a seatbelt 14 to 19% less than with a female passenger. You get the same results, just framed in a different way. So again, you want to make sure that you're always justifying by meeting those assumptions and conditions. You want to show as much about your calculations as you can. In this case, we can just write down what function we used on our calculator, write the interval. It's good to document. Of course, we always have to do NP, NQ. It's good to document all your pieces. The more correct information you display, the better you show you understand what you're doing. And then we always need to interpret, and we always need to make sure our interpretation has the confidence level, what parameter we're looking at, proportion, what is the actual interval, and make sure we have some context to it. So as always, if you need some help, if you have some questions, please do ask me. Make sure you watch this all the way to the end because I do have another problem coming up here, and I'm going to have some questions pop up about this problem right here. So watch to the end because there'll be a few questions that pop up that you need to answer. and then of course do some practice. As always, ask me for help when you need it, and good luck.